Hello, everybody. Uh, Welcome here on this rainy night to my desk in the mountain village of Aulla in Tuscany, Italy. On YouTube, you can find various versions of a talk called The End of Spacetime by Nima Arkhani Hamed. I want to summarize some brief points that Arkhani Hamed makes before moving on to make some further observations to carry forward the theme. Now, he mentions that in the past decade, quote, new mathematical structures in combinatorics, number theory, and geometry that in concrete examples can be seen to give rise to the rules of space-time and quantum mechanics. Right? So he's talking about the combinatorial S matrix or scattering matrix, right? So these are the possible ways, right, that, for instance, gluons interact, right? So and the permutations, right, involving, let's say, two gluons interacting with one gluon, or one gluon interacting with two gluons, and all the possible ways that can happen, right? So this is the domain of combinatorics, all possible combinations of some series, some set. All right, so these then produce three particle amplitudes, right? So these triadic configurations, right, then amalgamate into more complex structures, right? And the pieces, the individual building blocks, he says, don't have, right, space-time or quantum mechanical interpretation, but the full volume does, right? And in a very precise sense, the rules of space-time and quantum mechanics arise as derivatives or derivative notions from this more abstract mathematical structures, right? Now he emphasizes that the fluctuations, right, these different scattering patterns, right, aren't occurring in space-time, right? Now regarding this, the amplitude, right, as he said, the individual building blocks of the amalgamations have no space-time or quantum mechanical or quantum mechanics, right? So the volume of the shape, of the amalgamated shape, right, gives us the amplitude for the scattering processes, right? So in a sense, right, you could correlate or view these amplitudes of scattering processes, right, as on the way to matter, right? And so then what you think of is information structures that produce matter in information physics theories, right? And so then geometry is produced by permutations of the scattering processes, right? So you're on the way from these mathematical structures to geometrical patterns, right? Then on to, the matter and all those entities that comprise the cosmos. Now, the permutations, one way you can think about them is, as Arkhani Hamed points out, right, you can line up the numbers 1, 2, 3, 4, 5 on the bottom, and on top of that, another set of 1, 2, 3, 4, 5. The bottom, right, represents space. The top line represents time. Now, for instance, you could then correlate the 1, draw a line, go up to 4, right, and maybe on the bottom the number 5 then goes up in a line and correlates with number 3, right, etc. So you're going to get all these crisscrossing lines, right? And all the various possibilities of those are the permutations of these S matrix, right? The scattering matrix, scattering possibilities, if you will. And this represents one dimension plus one dimension. We have one dimension space, one dimension time in there, but this can be generalized, right, to fit the 3 plus 1 dimensions of our actual world. Right? So that's very important, right? And these mathematical structures of the combinatorial permutations give rise to both the space-time and the quantum mechanics. Again, another, this is the main point of his talk, is that space-time and quantum mechanics may be generated by something that is more primitive. And what he's suggesting is that what is more primitive are the scattering processes and the combinatorial structures, the mathematical structures, right, that represent these. There are some problems, admittedly, right, with this model. He doesn't go into it much in his talk on YouTube, but in the book that he published with some colleagues called The Grassmannian Geometry of let's see what the title of it was. The Grassmannian Geometry of Scattering Amplitudes. That's it, excuse me, published by Springer. He points out that, quote, we have yet to see, right, locality and unitarity fully emerge from more primitive principles in a completely satisfactory way, right? And so the locality and the unitarity, of course, are the two foundations, the pillars, right, of quantum field theory, right? So some things still need to be worked out. But anyway, what you can discern in this, now I'm going to go beyond what Arqani Hamid has to say. But the model he's proposing, that mathematical structures comprising these combinatorial sets, right, are what comprise, right, or give rise to space-time and quantum mechanics, right? This is congruent with the Neo-Pythagorean, or sort of a Platonic mathematical structures, right, model that, you know, has math, numbers, algorithms, numerical patterns, mathematical structures, right, giving rise to and comprising the cosmos, right? And, you know, there are ancient anticipations of this. For instance, right, in not only in the Greco-Roman literature, but also in like the Sefer Yetzirah, the Book of Formation, right, which had a huge impact on Jewish mysticism. But the fact is that the Sefer Yetzirah, right, is just not a mystical treatise. It's also an attempt at an ancient scientific explanation of the universe. You know, how does the universe arise, right? So, you know, you think of alchemy. Pre-scientific alchemy was a combination of, you know, the predecessors to scientific chemistry, right, merged, of course, with that time's ideas in religion, mysticism, magic, even, etc. Right, same thing for astrology, right? So the predecessor to astronomy, right, merged with some religious ideas at that time, and this is what Sefer Yetzirah does. And even you can see that, you know, the gluon, right, scattering matrix that Arqani Hamid talks about, right? So the possibilities, right? You have either two gluons interacting with one gluon, or one gluon interacting with two gluons, right? And then it scatters in this triadic configuration and gives rise to this triadic pattern. All right, so you think of Sefer Yetzirah, its explanation for the universe is that everything is built out of various combinations, right, of the divine letters, which function also as numbers, of course, because, right, in Hebrew, for instance, the first letter of the alphabet, Aleph, functions as the number one, the second letter of the alphabet, Beit, functions as the number two, etc. Right, and so the underlying configuration involves three letters. The first three letters of the sacred tetragrammaton, Yod, He, Vav, right? So not all four letters of the full tetragrammaton, Yod, He, Vav, He, or Yod, Ke, Vav, Ke, but Yod, He, Vav, right? And I'm not quite sure why the Sefer Yetzirah, you know, starts with three, though there's some clues in the text. But in any case, right, if you consider this symbolically or metaphorically, it does make sense, because what the understanding of the Yod He Vav, of this divine name, is that it was correlated with, right, the Hebrew verb of being, the copula, the verb of being. So, right, the universe is, how do you explain what is? Well, what on some higher level, the power of isness, of existence, what gives rise to things, right, is represented by the divine name that denotes being, Yod He Vav He, right? Because it's you know, understood to be a form, a very peculiar form of the verb of being. So if you understand it symbolically, you can see why it can even be used in one of these pre-modern mystical scientific treatises like the Sefer Yetzirah. Right. So it's not that the Sefer Yetzirah was anticipating, modern ideas like Arcani Hamidis, right? That the S matrix permutations, right, and these triadic configurations that then, right, give rise to larger amalgamations, right, can then explain, right, the origins of space-time and quantum mechanics. No, but you can look at the similarities in the Sefer Yetzirah and say, all right, so we can see that as a parable, as an analogy, as a metaphor, right, for what science is telling us. Right. And so you also take into account, right, the impact of religious ideas in the history of science, right? So many scientific ideas, right, through the many centuries in Western civilization, for instance, right, were inspired by certain religious ideas that were then applied to a different field of knowledge, right, the hard sciences, for instance, right? And but now, if you try now, Stanislav Krajewski, right, he's explained that mathematical models that are used in religion, right, are sometimes fine, so long as they function as metaphors, right, to illustrate a certain idea. But these mathematical models in religion are not productive of new knowledge, right? The way that we see, the hard sciences being productive, right? And certain models leading to new knowledge, right? So this doesn't happen when we take these, like Foncusa's mathematical models in religion, right? It's a nice illustration of something that was already known. It doesn't lead to new knowledge, new models of knowledge, right? There was an interchange between Arcani Hamidi and a sociologist after one of his presentations on this end of space-time, and Arcani Hamidi made the point that, right, physics is aiming for the absolute truth, but it can never arrive at truth as such, the absolute truth. We just have approximations, ever more sharp approximations approaching truth as such. But truth as such is beyond the scientific method, right? And the sociologist then retorted that this is a theological notion at its root, the idea of truth as such. And I think Arcani Hamidi then made some comment about that his approach is atheistical, but be that as it may, it's ultimately irrelevant, because the sociologist's point was in fact correct if you look at it just from a historical angle, right? That the idea of absolute truth, to which you cannot arrive, but you can approximate, right, and arrive at closer approximations of that. That originates from theology, right? Historically speaking, right? And of course, it's Arcani Hamidi is not using it in a theological sense, right? But the language and the basic underlying concept does come from Western theology, right? So, the truth as such is not the domain of science, or the hard sciences, right? So because like physics, for instance, it does not tell us what the cosmos is. It tells us how it functions. It does not tell us what space is, right? It tells us how it functions. And this brings me to another presentation you can find on YouTube by Sabine Hassenfelder, a physicist, right? So it's called Did the Big Bang Happen? Right, and has a subtitle you see on the screen. So we don't know how the universe began, right? So, and there I want to do a few quotes that she offers, right? Most physicists think that the Big Bang singularity is a mathematical artifact and not what really happened. It probably just means that Einstein's theory stops working. Right? All we can say is that if we extrapolate Einstein's equations back in time, we get the Big Bang singularity. We think this isn't physically correct, so we don't know how the universe began, and that's it. Right? When it comes to the question, I'm continuing her quote later on in the talk, when it comes to the question how the universe began, we are facing the limits of science itself. It's a question I think we'll never be able to answer. Right? Unquote. So, all of these ideas that the universe began as from a black hole or from a zero size universe that then transitions into the universe we have now, right, with this transition phase of the Big Bang. All of this, we could call it, and here I'm borrowing a point from Hassenfelder again, these are